Good morning, everyone. Yeah, so my name is Steve Bega, and I work for a company called Animex International, and we do a whole host of things to do with kind of wildlife connectivity all across the world. But today, it's kind of my pleasure to talk to you about one of my favorite projects from the last year, and that's about how we've kind of designed, installed, and began monitoring some temporary arboreal bridges for a species known as the hazel dormice within the UK. And also just want to thank quickly my co-authors on this, who aren't able to join us today. That's Hattie Taylor and Ian White. Now, what is a hazel dormice? Now, they are literally the cutest animal in the world, and I will put it upon anybody to try and convince me or anybody else otherwise. Within the UK and Europe, they are a heavily protected species. They are a sign of good habitat and good indicator of a healthy ecosystem. Their way they utilize a whole different range of food sources within the forests and hedgerows within Europe, different berries and nuts at different heights, different leaf and nesting materials at different heights throughout the different seasons. So typically, if they're there, a lot of other things are there. But they are facing a lot of challenges with growing development, particularly in kind of rural and farmland areas. And they rely on the connectivity of hedgerows between woodland parcels. And as development happens, a lot of these hedgerows are getting cut out. And that's where our bridges kind of help to plug those gaps. See if this video will play. Imagine there's a video of a bridge with loads of like squirrels and dormice running all over it. But and I've had the pleasure over recent years of kind of designing and fabricating and installing arboreal crossings for permanent structures on various different roads. And most recently, we've been kind of designing one for the high-speed rail that's kind of going north to south from London to the northern parts of the country. So when we were approached last year to come up with a kind of temporary version of these otherwise permanent structures, it was kind of really exciting challenge for us to do. So, and here are just some examples of our permanent structures installed. These are kind of retrofitted examples, obviously onto the underside of culverts or on the kind of parapets of road bridges. Typically, there's the safety standards and the design life requirements of these structures within the UK is very, very high. So we're looking at 25 to 50 years. They're technically, in my opinion, they're kind of slightly over-engineered for their purpose, but in order for them to be implemented on roads, they need to be engineered in that way. Otherwise, they're just not going to be able to be approved by engineers. And there's some examples of the structures going over roads in various other different circumstances. In various different situations. We have new housing development areas. We have one in Denmark that's going to a substation for an electrical company. So how do we go from those permanent bridges to the temporary ones? So to give our brief was that these need to be easily installed, easily maneuverable, and obviously durable. And we had 5 bridges across a site that we were working on to basically plug the gap where hedgerows were being removed as part of a large water pipeline redirection scheme. And as I said, the hedgerows for dormice are a vital part of their connectivity. So we wanted to ensure during the lifestyle of this project that connectivity is retained, but then also that access to certain areas can be easily achieved by removing these bridges as and when they needed to be via both people, vehicles, or the actual pipeline excavation itself. So to keep things simple, we wanted to see if we could use this easily accessible materials in construction materials such as scaffolding, and we call it Harris feet fencing, construction feet fencing, to act as the kind of weights and anchors to the floor. This is obviously an early engineering drawing of it. The actual brackets you can see here to connect the scaffolding together didn't actually give enough freedom and movement to adjust with the kind of adjusting ground that was there. So we did actually make these a little bit more maneuverable and flexible. And then here's some pictures of, on the left-hand side, we have an example of where the hedgerow has been removed. And then on the larger picture on the right-hand side is where the gap has been plugged. Typically, although obviously there's a kind of higher arboreal connectivity canopy there, the typical hedgerow within the UK is kind of like waist to shoulder height. And obviously for access of these for individuals to be able to move sections quite easily, we had to maintain that low height, because obviously, although if we wanted to put them higher, just logistically, it's just not feasible in this situation. And again, here are just some more examples of the bridges being installed on a couple of different locations. We also have an example of the trail camera configuration installed. What you didn't get to see because the video didn't load, but the dormice, they just climb over everything. So actually trying to monitor which parts of the structures they're using, it can be quite a challenge because you need to cover everywhere. So you can see here in this bottom right, we've got a configuration of kind of 3 cameras on the outside, then 1 on the inside. And although we installed these right at the end of the kind of active season last year before they went to hibernation, so although we put cameras up, we didn't actually get any dormice utilizing the structures. We also had some issues where in some areas the bridges weren't connected to the hedgerow. And we told the biologists on site, you need to, whatever you've taken out of the hedgerow, plug the gap and just put the dead material onto the bridges to make sure that they're actually connected to the hedgerow. Otherwise, it's completely pointless. So that's all been sorted. My last thing I did before I came here was box up a load more cameras to send back to site. We also had a lot of cameras stolen last year, so that's going to be fixed. But this is just a quick snapshot of, although we didn't capture dormice on the structures yet, there's a lot of other kind of hedgerow species, particularly birds, that are obviously entering into the structures. And we've got some birds of prey kind of lurking on the top, while the other animals are quite safe within inside of that. So, as I said, our next steps really it's just to start monitoring again at the start of this active season, and we'll see if they get used by the intended species over the course of this summer. Hopefully they will, and then we'll hopefully be able to report back on that soon. So yeah, over to questions. I'll also say I do have some stickers, in fact, like logo here of dormice if anybody wants. So yeah, we've got to have the table out there if we. Okay, yes. Really good question. So the question was the different materials, does it get hot and temperatures, and how the different elements of the structure do they get used? So yeah, really good question. So typically the early designs utilize a kind of metal framework with timber on the outside. The timber has since been replaced by recycled plastic, but obviously to mimic the kind of texture and temperature elements of timber. We've seen from the observations the dormice, they just climb over everything, and the heating up of the material doesn't seem to bother them, but particularly they're nocturnal, so they will actively move more so at night when obviously temperatures are lower. But obviously monitoring, this is the first time we've been able to monitor 5 bridges in a short area, so we'll see if they're moving during the day or not. Will be really, really interesting to find out.